Hello and welcome to our video, section 2.1, verbal and algebraic equations. After watching this video, you should be able to translate a verbal equation into an algebraic equation and vice versa, and also identify the words is, equivalent, and equals as verbal equivalents to an equal sign. So to start, we're going to review this chart, which we have already looked at in discussing verbal and algebraic expressions, different ways to talk about addition, subtraction, multiplication, division, and how we might say a variable as opposed to just saying x. We have a number x or a value x and so on and so forth. Well, as we moved from expressions to equations and added an equal sign, we have to do the same thing when moving on to verbal and algebraic our equations. So we are going to add the equal sign to this chart, and you'll see now we have the words is, equals, and is equivalent to, all meaning that we need an equal sign. So now instead of just having the algebraic expressions involved, we're also going to add equations to the mix, and that means we need to add some words to our chart. Here are some examples. We might have something like 6z minus 15 equals 45, and we'll be asked to translate that into a verbal expression. I came up with 6 times a number reduced by 15 is 45, and you'll see that's the key new word, is that word is. Okay, there's other ways I could have said it. Like we've mentioned before, all of these, there's more than one correct answer. Here's one example, and you can compare what I came up with to what you came up with. Here's some more examples in the opposite direction. Now we have the verbal equation, 7 times a number squared is 5 times the difference of k and m. Take a moment, take a shot at this. 7m squared equals 5 times the quantity k minus m. It's kind of how we would normally read that off if we saw it in a math problem. But you can see we have 7 times a number squared. 7 times a number squared is 5 times the difference of, and that's where we get these parentheses, k and m. For our next example, we have 80 minus 15 times a number is 15. Take a moment, take your own shot at it. And we should get 80 minus 15n, equals 15. 80 minus 15 times a number is 15. Okay. Now what's nice about these problems is we do have a clear, concrete answer. So this is what it should look like. There's not much room for interpretation on these sorts of problems. Now the last new thing that we're going to cover here is formulas, and these are equations that are given to us where we have multiple variables to consider, but they're not necessarily labeled as clearly as, say, a number x. They will give us a set of values to which we don't know the actual value, and we have to kind of pick our own variables. So like it says here, multiple variables, but you pick which ones they are going to actually be represented as. So for example, we have the area of a triangle equals the product of 1/2 the base and the height. Okay, now that already sounds like a lot and intimidates a lot of students, but let's really break down what that's saying. Like I said, we're going to have multiple variables. So here we have the variable area. Okay, the area of the triangle. We don't know what that area is going to be, so we give it a variable and we call it capital A. That's a pretty common practice in math. We also have the base. We're taking the product of half of the base. The base is the bottom part of the triangle. We'll call that B. And the height, that's how tall the triangle is, and so we'll call that H. So we've got our 3 variables. We've determined what letters we're going to use, and I keep it basic, A, B, and H for area, base, and height, and move from there. After we've identified what variables we're going to use, we're also going to look for some of those key phrases from our chart that are going to tell us am I adding, subtracting, multiplying, and so on. So here, my key phrases are equals and the product, meaning multiply. So I know I'm going to have whatever the area is, that's A, that equals, so I need an equal sign, and then product, I'm going to do some multiplication of, and it looks like 3 things, 1/2, the base, and the height. So ultimately I end up with the area of a triangle equals the product of, all this is being multiplied, 1/2 of the base and the height, all multiplied together to give me what the area is. And that's formulas in a nutshell. Now, obviously you'll get several more examples of these in class, but the idea here is, again, look for those multiple variables, identify what are the values given to you in the verbal equation that you don't know, assign a variable to them, look for the key phrases, and then piece everything together, okay? Remember, practice makes perfect with this, so if you're a little confused, check back through the cloudy spots in the video, and then of course come to class with lots of good questions and we can practice this more together as a group.